Alright, so today we're reviewing for our first quiz for the proportional relationships chapter. So the first thing we did in this chapter was looking at whether two ratios were equivalent or proportional. So if you look at your two ratios or fractions, all we need to do is to see if they're equivalent is either simplify the two fractions and see if they come out to be the same number, or divide each of them and see if they come out to be the same number. Alright, so the way I did it over here was just simplifying. So I'm just going to type into my calculator the first fraction, which is 12/18, and that simplifies down to 2/3. Then if I type in the second fraction, 3/4, that's already simplified. It's still 3/4. So when I look at these, I can see that they're not the same, so I'm going to say no, that's not a proportional relationship. The second thing we did in the chapter was finding unit rate or unit price. And to find unit price, we divide the price of the item divided by the quantity, so how much of it you're getting. So our first example here says, which is the better buy? And we've got two different size packages of fruit snacks. So what we're going to do to figure out which one's the better buy is we're going to find the unit price of each one by dividing. So step one says find the unit price for the first box. So for this box over here, we said we're going to divide price divided by quantity. So my price is going to be $5.28, and I'm going to divide that by 42 since that's how many pouches I'm getting. So I'll take my calculator and type in $5.28 divided by 42. Now I'm going to get this big long decimal, but because we're talking about money here, we can only keep two decimal places. So I need to cut this off after the 2. So the 5 is going to tell the 2 to round up. So this is going to be 13 cents per pouch. So each pouch in that package costs 13 cents. Now I'm going to find the unit price for the second box. So I'm going to do the same thing. So I'm going to do the cost, which is $3.28, divided by how many of them I'm getting, which is 24 pouches. So $3.28 divided by 24, and I'm going to get this number. Again, it's money, so I can only keep two decimal places. So I need to cut this off after the 3. So 6 is going to tell 3 to round up. So this one's going to round up to 14 cents for each pouch. So then I just need to say which one is the better deal. Alright, so I could pay 13 cents for one package of fruit snacks, or I could pay 14 cents for that same package. I'd rather pay less. Okay, so that first option is going to be the cheaper one. The next thing we did in this chapter was looking at a table of values and deciding if that's a proportional relationship. So if I look at my table here, the first way you can tell it's proportional is to see if there's some number that you could multiply or divide by every time to get from X to Y. When your numbers get bigger like this, it's a little bit harder to figure that out. So our backup plan is we can divide. Alright, so step 1 says find the unit price for each row by dividing Y divided by X. The first column in your table is always your X. The second column is always your Y. So for each one of these, I'm going to divide Y divided by X. So I'm going to do 200 divided by 5, 350 divided by 10, and 500 divided by 15. Alright, so you take your calculator and you divide each of those. And if you do that, you should get 40 for this one, 35 for this one, and 33.3 repeating for this one. So when I look at these, I can see they didn't all come out the same. So I'm going to say no, this is not proportional. Now for my reason why, when I'm thinking about a proportional relationship, what that means is that there's a constant ratio between these two variables. And when I look at these, this is not constant. It's not staying the same the whole time. So I'm going to say no because the ratio, okay, which is just the fraction of cost to number of tickets, is not constant. Okay, the ratio of cost, which is our Y, to number of tickets, which is our X, is not a constant ratio. I'm not getting the same thing each time, so that tells me it's not a proportional relationship. You could also, for your reason why, say, no, it's not, because if I divide y by x each time, I don't end up with the same number, or something like that. All right, on the back, we have another table, but this one we're actually going to fill out and then talk about why it's proportional. So it says you pay $15 for 5 milkshakes at Sonic. Each milkshake costs the same amount. Fill in the table above to show how much each number of milkshakes will cost. Well, if I look at the table, the only point that I know is this last one, which is that 5 milkshakes cost $15. So if I take the one I know and I divide, that'll give me my unit rate. So I'm going to divide y divided by x. So 15 divided by 5, which is 3. That tells me that 3 is my unit rate. Each milkshake costs $3. It's the price for one. So one milkshake is going to be $3. If each one is $3, then that means that 2 would cost $6, 3 would be $9, and 4 would be $12. All right. In other words, you take the number of milkshakes, you multiply by 3, that'll give you the cost. So we filled in the table. So now part B, why are these quantities proportional? All right, so there's a few different ways that you could describe this. You could use the constant ratio argument that we used in the last question and say they're proportional because the ratio of cost to number of milkshakes is the same the whole time. You could also say the unit rate is the same the whole time. All right, so I'll use that answer for this one. So I'll say I know it's proportional because the unit rate is always $3 per milkshake, no matter how many you buy. Okay, so I'm saying my unit rate is the same each time, which is really the same as saying if I divide y divided by x, I'm going to get the same answer every time. The next thing we looked at in this chapter was if you have a graph, how to tell if that is a proportional relationship. So when I look at a graph, there's two things that I'm looking for to decide if it's proportional. All right. First thing is it has to be a straight line. Second thing is that it has to go through the origin, which is just the point 0, 0. So when I look at this question, it says which one is proportional and why. I'm going to look at my two lines. Tank B is the one that's a straight line that's going through the origin. It's going through 0. So I'm going to say tank B because, and then I'm just going to list my two things. It is a straight line that goes through the origin. All right, and my last question here. For this one, we're actually going to graph it and then talk about whether it's proportional or not. So it says two students compared the amount of time they played video games in a week. They decided that for every 3 hours that Tyler played, Tiffany played 5 hours, as shown in the table below. So first, graph the data. So when I go to make my graph, I'm going to put a title on here that is anything that has to do with the question. So this is talking about video games, so I'll just call it video games. Now you have to label the x and the y axis. Okay? Your first column is always your x, second one is always your y. So the x is what goes on the bottom of the graph. So I'm going to put Tyler down there, so that's his hours that he's playing. And then the second thing, your y, that goes on the side. So I'll put Tiffany on the side, and that's the number of hours that she's playing. And now I'm going to graph my data. Now, I messed up when I put this graph on here, and I meant to put one that went up to 15. I only put it up to 10, so we're going to ignore this last point on the table. So that's my fault. And so we'll look at our first point. So we have 3 for Tyler and 5 for Tiffany. So I'm going to go over to 3 and up to 5, and there's my first point. Now we have 6 for Tyler and 10 for Tiffany. So that's going to be right there. And then I'm just going to connect these. All right, and I can see that I end up with a straight line that's going through the origin. It's going through 0. So it says, does the graph represent two quantities that are proportional to each other? Explain. So just like up here, okay, we're looking for a straight line through the origin. So I'm going to say yes, because it is a straight line that goes through the origin. Alright, so that's it for the review for the quiz. So hopefully you should find that the quiz is exactly like this.